Body poses a scenario where scientists line up 1,000 nuclear bombs in space and then set them all off in order, like dominoes. In fact, Chung's idea is based on a real phenomenon known as nuclear thermal propulsion, sometimes called nuclear pulse propulsion. As it turns out, nuclear propulsion produces very little radiation if the engines using it are activated in space instead of on Earth. And the benefits include reduced energy use, reduced exposure to cosmic radiation, and speedier rockets. Nuclear thermal propulsion, NTP, is a type of propulsion technology that uses nuclear energy to heat a propellant, typically hydrogen, to extremely high temperatures. The heated propellant is then expelled through a nozzle to produce thrust, similar to how traditional chemical rockets work. However, nuclear thermal propulsion offers several advantages over chemical rockets, such as higher specific impulse, fuel efficiency, and potentially shorter travel times for space missions. Here's how nuclear thermal propulsion generally works. Nuclear reactor. The core component of an NTP system is a nuclear reactor designed specifically for propulsion purposes. This reactor uses nuclear fission to generate heat. Heat exchanger. The heat produced by the reactor is transferred to a working fluid, such as liquid hydrogen, through a heat exchanger. This process raises the temperature of the working fluid to very high levels. Propellant expulsion. The high-temperature working fluid is then expanded through a nozzle, generating thrust as it exits the spacecraft at high speed. One of the key advantages of nuclear thermal propulsion is its high specific impulse, which is a measure of how efficiently a propulsion system uses its propellant. NTP systems can achieve specific impulses significantly higher than those of chemical rockets, allowing for faster and more efficient space travel. As for the correlation with existing nuclear power plants, there are some similarities and potential synergies, but also significant differences. Similarities. Both nuclear thermal propulsion systems and nuclear power plants rely on nuclear reactions, fission, to generate heat. They both involve the use of nuclear fuel and require sophisticated engineering to manage nuclear reactions safely and efficiently. Differences. Nuclear power plants are designed to generate electricity for terrestrial applications, such as powering cities or industrial facilities. They use the heat generated by nuclear reactions to produce steam, which drives turbines connected to generators to produce electricity. In contrast, nuclear thermal propulsion systems are designed for space travel and focus on using nuclear energy to directly propel spacecraft. Synergies. Research and advancements in nuclear reactor technology, materials science, and safety protocols from nuclear power plants can potentially benefit the development of nuclear thermal propulsion systems. For example, innovations in reactor design, fuel efficiency, and radiation shielding could translate into more capable and reliable NTP systems for future space missions. Overall, while there are connections between nuclear thermal propulsion and existing nuclear power technologies, they serve distinct purposes and operate in different environments. Space versus Earth. Collaboration and knowledge exchange between experts in these fields can contribute to advancements in both areas of nuclear technology.